It was impossible to ignore the numbers circulating behind the scenes in the automotive industry. Elon Musk, always direct, had made it clear. The cost of battery cells had doubled, and the price of lithium had soared a staggering 500%. It's as if the fuel powering the electric revolution had turned to gold. And not just any gold, but the kind of gold everyone wants and few can get. For those who closely follow the world of electric cars, this increase isn't just a market detail, it's a watershed moment. Imagine trying to maintain affordable prices when raw materials are soaring like this. There's no miracle cure, and Musk, with his characteristic style, practically warned, either change course or the electric future could get stuck in a cost bottleneck. The curious thing is that this price hike didn't just fall from the sky. Demand for lithium has grown like never before, driven by automakers and electronics manufacturers who have invested heavily in the same battery chemistry. However, global supplies are limited, and mining can't keep up with the market's voracious appetite. The result? A race for supply contracts that feels more like a multi-million-dollar auction. For Tesla, whose goal has always been to popularize electric cars, this is a logistical and financial nightmare. If the cost of the battery, which is the lifeblood of the vehicle, rises like this, the final price will also follow suit, and goodbye to plans for cheaper models in the short term. Another factor that raised alarm bells was the geographic concentration of reserves. Much of the lithium comes from a few countries such as Chile, Bolivia, Argentina, and China. This means that any political instability, regulatory change, or even natural disasters could affect global supply within weeks. For Musk, relying so heavily on a resource with such vulnerabilities is like building a skyscraper on quicksand. One market fluctuation and everything could collapse. Perhaps that's why he's been so emphatic about seeking viable alternatives, before the problem stops being a cost issue and becomes a pure lack of raw materials. While most automakers are still trying to cope with this impact by making cost cuts here and there, Tesla seems to be a few steps ahead. Musk knows that simply tightening his belt isn't enough. He needs to redesign the entire map. After all, a 500% price increase for a key component isn't something that can be absorbed with simple adjustments. It requires tweaking the very backbone of the technology. It's almost like changing an airplane's engine mid-flight. Risky, but necessary if the goal is to continue flying higher than the competition. The impact on the end consumer is inevitable. Even those who don't understand battery chemistry feel it in their pockets when a car that should cost less than $30,000 suddenly costs much more. And it's not just the purchase price that's scary. The prospects for maintenance and battery replacement also become more difficult. This creates a dilemma for those dreaming of an electric car. Wait for prices to stabilize, or pay dearly now to enter the electric era. Many believe the latter scenario is more likely, as demand continues to grow and government incentives aren't always able to offset the skyrocketing costs. Some experts point out that this lithium price crisis could be a blessing in disguise. It seems counterintuitive, but crises like these force innovation. When the traditional path becomes too expensive, it's natural for companies to start exploring alternative routes. And that's where new battery chemistries, more efficient recycling processes, and even more abundant substitutes come in. Musk, of course, makes no secret of his interest in these possibilities, hinting that Tesla is already testing something that could completely change the game. What few people realize is that, while the market was discussing the absurd increases in lithium prices, Tesla was already quietly working on a solution to break this dependence. Elon Musk reportedly initiated an internal project years ago focused on aluminum-ion batteries, a technology that, to many, seemed like a laboratory concept, but is now becoming a reality. The goal is simple but bold: to completely replace lithium batteries by 2026 and implement this change precisely in the brand's most affordable models. It's a move that, if realized, could break a cycle that has held back the advancement of mass electric mobility for years. What's most intriguing is that this transition didn't emerge as a desperate response to the current crisis. Musk had already hinted in interviews and at events that lithium wouldn't be the end point of the electric revolution. It's as if Tesla had anticipated the bottleneck and prepared for it before the market even realized it. Prototypes of aluminum-ion batteries, according to internal sources, are already in advanced testing stages and showing impressive results. The promise is so great that, behind the scenes, engineers and suppliers are already talking about reconfiguring entire production lines to accommodate the new cell type. Unlike lithium batteries, aluminum batteries are simpler to produce and don't rely on rare raw materials or those concentrated in a few countries. This means that, in addition to lowering costs, Tesla would be less vulnerable to geopolitical crises and absurd price fluctuations in the commodities market. For a company aiming to put millions of cars on the road, this predictability is golden, or rather, aluminum. And there's another detail that's noteworthy: the fact that this technology can be adapted to different vehicle sizes, from compact city cars to long-range SUVs. The decision to use the new battery first in the cheapest models isn't just a technical strategy, but also an image strategy. Imagine the market impact of launching an electric car with cutting-edge range, an affordable price, and no hidden lithium-ion tax. It's a direct hit on the main criticism consumers still have of EVs: the high initial cost. This change could attract an audience that until now has viewed Tesla from afar, seeing it as something out of reach, and now finds itself able to enter this world with a clearer and more sustainable value proposition. Naturally, transitioning to a new battery chemistry requires more than just swapping cells and tightening a few screws. The car's entire system needs to be adjusted to optimize use of the new technology. Thermal management, control software, electrical architecture, and even the physical design of the pack. Therefore, it's no surprise that Tesla is investing heavily in engineering and simulation before releasing any model into mass production. The goal is to reach 2026 with everything calibrated for a safe and impactful launch. If this change happens on time, it will also send a message to the rest of the industry. Today, many automakers are still in their infancy in the search for viable alternatives to lithium, while Tesla may be just steps away from becoming the first to put an aluminum-ion battery into mass production. It's like watching a race where one competitor is already rounding the final corner while the others are still searching for the right shoes. And Musk, as always, knows how to use this advantage to build anticipation and reinforce his image as a pioneer. When it comes to the true power of aluminum-ion batteries, the most impressive statistic is their energy density, around 600 Wh. To understand the significance of this number, just remember that the best lithium-ion batteries used today in electric cars barely reach 250 Wh. It's as if, suddenly, it were possible to store more than twice as much energy in the same space, without increasing the pack size or the vehicle's total weight. This leap changes everything, from range to overall performance, and that's precisely why Tesla is betting this technology can redefine the market. Imagine a Tesla Model Y equipped with this new battery. Today, the long-range model with lithium-ion offers around 357 miles of range, which is already respectable. But, keeping the exact same pack size, the new chemistry would allow it to surpass the 1,000-mile mark, more than 1,600 kilometers, on a single charge. That's the distance from São Paulo to Recife, without needing to stop even once to recharge. This comparison not only sparks the imagination, but also challenges all the excuses about range anxiety that still keep some consumers from electric cars. Such a gain doesn't just impact those who enjoy long trips. In everyday life, this translates into fewer stops, less reliance on charging infrastructure, and more flexibility to use the car without planning each trip. With a battery like this, Recharging could become as rare as filling up a combustion engine car during periods of full fuel and moderate use. And for those living in areas with fewer charging points, this range would be a game changer, paving the way for electric vehicles to conquer territories where they are currently rare. Another positive side effect is weight reduction. With such a high energy density, it would be possible to reduce the size of the pack and, consequently, reduce the vehicle's total weight by hundreds of kilograms. Lighter cars consume less energy, accelerate faster, and have better handling. This creates a virtuous cycle. Greater efficiency leads to greater range, which leads to greater efficiency. It's one of those improvements that feeds back into itself, enhancing all the other advantages of electrification. From an engineering perspective, reaching 600 kW isn't just a leap. It's breaking barriers that for decades seemed insurmountable. Many experts believed the physical limits of commercial batteries had already been nearly reached. And that's where Tesla's boldness comes in, challenging the impossible and finding a way to push those limits. This kind of innovation doesn't come without risks, but if you have a company accustomed to walking on the edge of the technological precipice, this is it. There's also a detail that's rarely mentioned, but makes all the difference. With more power in the same space, there's room to include new features without sacrificing range. Advanced entertainment systems, more efficient climate control, high-performance driving modes, all of these can coexist without the constant fear of losing range. For a brand that likes to add new features via software updates, this energy leeway opens up a nearly infinite range of possibilities. If a 1,000-mile range already sounds revolutionary, the durability of these aluminum-ion batteries adds an even more impressive layer to the story. We're talking up to 10,000 charge cycles before capacity drops to around 80%, which, in practice, means something close to 30 years of use from a single pack. For comparison, the most advanced lithium-ion batteries today rarely exceed 2,000 cycles, which translates to about 5 to 8 years of life under intense daily use. This leap isn't just technical, it completely changes the economic logic of owning an electric car. Imagine a vehicle that maintains its battery life for 3 decades without needing replacement. This not only eliminates one of consumers' biggest fears, the high cost of battery replacement, but also raises resale value to unprecedented levels. A 10-year-old Tesla would theoretically still have more than 2/3 of its battery life intact. And this prospect of longevity attracts even those who previously turned their noses up at electric cars, precisely because of concerns about accelerated degradation. But it's not just the time factor that draws attention. Aluminum's chemical stability makes it much less prone to problems like overheating and unwanted reactions. One of the biggest culprits in lithium batteries is the formation of dendrites, those sharp microstructures that can pierce the internal separator and cause short circuits. In aluminum, this phenomenon practically doesn't occur, even with rapid and intense recharges. This means less risk of catastrophic failures and, consequently, less need for complex protection systems. This structural strength also translates into greater reliability for use in adverse conditions. Whether in very cold or very hot climates, aluminum tends to maintain more stable performance, avoiding the sudden drops in range that so many electric vehicle owners experience in winter. For commercial fleets or vehicles operating in remote regions, this can be a decisive factor for widespread adoption. Another little discussed advantage is that, with such durability, the production of new batteries could be reduced in the long term, reducing the environmental impact of manufacturing and disposal. This creates a sustainable cycle rare in the industry. Less resource extraction, less waste, and more use of what's already been produced. For a company that has always built its image on the banner of sustainability, this argument is powerful. While the durability of these batteries is already impressive, the recharge time is the final blow to the limitations that electric cars still face. Aluminum-ion technology promises to charge a full pack in about 15 minutes, And we're not talking about going from 20% to 80%, but a full charge, without compromising safety or reducing lifespan. This is possible because aluminum ions move through the electrolyte up to 3 times faster than lithium ions, ensuring a much more efficient and stable energy flow. For the driver, this means the time spent at the charging station can be less than the time it takes to get a cup of coffee. This speed completely changes the dynamics of travel. Today, even with the fastest chargers, a Tesla equipped with a lithium battery needs about 25 to 35 minutes to reach 80% charge. With the new chemistry, what was previously considered a fast charge will seem like an eternity. It's like swapping the slowness of an old cell phone charger for a state-of-the-art turbocharging system, only applied to an entire car. What's more, it doesn't face the thermal risks that force lithium batteries to slow down their charging to avoid overheating. Another important point is that this efficiency doesn't come with added complexity. On the contrary, because aluminum handles temperature variations better and doesn't suffer from dendrites, it's unnecessary to invest in such elaborate or expensive cooling systems. This not only reduces manufacturing costs, but also increases the reliability of the entire system. Fewer parts to fail means less maintenance over the vehicle's lifespan, an argument that wins over any consumer who has ever been frustrated by costly repairs. It's also worth noting that, with such fast recharging, the need for massive batteries to ensure range could decrease. Cars could have smaller, lighter, and cheaper packs, allowing for the fact that, if needed, it only takes 15 minutes to fill the tank. This approach optimizes resources and could be the missing step toward mass-market electric vehicles, especially in markets where price remains a barrier. It's easy to imagine the impact this would have on commercial fleets. Delivery trucks, taxis, and ride-hailing apps could keep vehicles running virtually 24 hours a day, with minimal breaks for recharging. Idle time would drop dramatically, increasing productivity and reducing operating costs. In such a scenario, it's no exaggeration to say that urban logistics and even long-distance road transport could undergo a quiet revolution. While recharge speed already seems like an unbeatable advantage, what truly cements the advantage of aluminum-ion batteries is the raw material itself. Aluminum is simply abundant. Its reserves are estimated to be about 18 times greater than those of lithium. And most importantly, they are spread across dozens of countries, drastically reducing the risk of supply crises. There is no aluminum triangle concentrated in a few strategic territories, as is the case with lithium. This means that, even in the face of political or trade turmoil, the supply chain remains stable. This abundance brings another obvious benefit: price. Producing a kilowatt-hour of capacity with aluminum costs somewhere between $15 and $25 compared to $55 to $100 for lithium. It's such a large difference that it's almost unfair to those still clinging to the old model. Putting it into practical terms, a 63 kWh pack, like the one used in the Tesla Model 3, could have its cost reduced from over $6,000 to just over $2,000. This savings not only creates room to lower the car's final price, but also increases profit margins, something any manufacturer loves. Another relevant aspect is that aluminum already has a consolidated global infrastructure for extraction, refining, and transportation. There's no need to reinvent processes or create complex logistics routes. Simply adapt what already exists. This ease accelerates the transition and avoids bottlenecks that could delay the adoption of the new technology. Furthermore, as it is a widely recycled metal,